All right, so we took a quick break there because I realized that the numbers I needed were not, in fact, right in front of me. But we're back now. So in this particular problem, the mean square between groups is going to be equal to 79.323. So again, this is a number that describes how spread apart our different sample means are from each other. The mean square within is going to be equal to 10.665. And again, this describes sort of how spread out our responses are within a particular sample. And we're going to use these two numbers to calculate our F statistic. So to calculate F, all we're going to do is plug them in. So we've got 79.323 and 10.665. If you divide this out, you get an F statistic of 7.438. Okay, so we have our test statistic here. The test statistic, as I mentioned before, gets plotted on one of these F distributions. And F distributions are another one like the T distribution that has slightly different shapes for different sample sizes. I'm just going to be representing it as sort of a vaguely right-skewed hump. But what we're doing is coming up with a test statistic that tells us where on this sampling distribution our particular set of samples falls. And specifically, with 0 being the smallest possible F value you can have, we have an F value that's 7.438. Once we have this value plotted, the area under the curve to the right of our F statistics gives us the probability of obtaining an F statistic this large or larger, assuming that all groups really did have the same true level of death penalty support in the population. And as we said before, if it's a very low chance, we're going to take this as evidence that they don't really have the same levels of death penalty support in the population. If it's pretty likely you would see an F statistic this large or larger, given that all groups had the same true mean levels of support in the population, well, we'll say we don't have any evidence that that's not the case, because this would be pretty likely according to our standards. And our standards, as you remember, are going to be based in our alpha level. The alpha level is chosen by the researcher, and common values are 0.05, 0.01, and 0.001. So in this case, I'm going to say that our alpha level is equal to 0.01. So the last question we have here is our F statistic big enough that our p-value is less than 0.01? If it is, we'll have evidence that attitudes about the death penalty are different among these three groups. So our final step in conducting an analysis of variance test is to decide whether to reject the null hypothesis. And we do this with a p-value. In this case, for an F statistic of 7.438, p is equal to 0.0013. In other words, there is a 0.13% chance that we would see an F statistic as large as 7.438 or larger if Black, white, and Asian people had the same mean level of death penalty support in the population. So in other words, if the null hypothesis is true, we would only see an F statistic this large or larger 0.13% of the time. So I'm going to write that out. Alright, so again, if the null hypothesis were true and the mean level of death penalty support was the same for each group, we would only see an F statistic as large as 7.438, it's an 8, or larger 0.13% of the time. Our alpha level, as I said, was 0.01, and our p-value here is 0.0013. So our p-value is smaller than our alpha level, and that means we're saying it's too unlikely that we would have gotten samples that look like this from a population where the null hypothesis were true. And so we're going to take this as evidence that the null hypothesis is not true. In other words, we're going to say this is evidence that goes against the idea that the mean level of death penalty support is the same for these three racial groups that we're looking at. And that would be our analysis of variance test. So here we're going to reject the null hypothesis, and we would say that the difference between groups is statistically significant. We'll say the difference between sample means, good to be specific, is statistically significant. Okay, so that's an example of analysis of variance. The last thing I'm going to do is going to be to go back to the PowerPoint and just go over what we have learned from this test and what we have not learned from this test.